A rational expression is any expression that can be written as a quotient of two polynomials. So let's look at three examples of rational expressions. They're listed as 5 over n, x over x plus 6, and x squared plus 3x plus 2 over 4x squared minus 1. What we see in all three of these examples is that they're algebraic fractions. And so throughout our work with rational expressions, we'll be dealing with fractions. Remember that rational expressions are related to a term that you may have heard before, a rational number. And a rational number is defined as any number that can be written as a quotient of two integers. So you can see the similarities in the definitions of both rational numbers and rational expressions. For now, let's talk about rational expressions. First, we want to learn how to identify restrictions on rational expressions. And so sometimes replacing a variable in a rational expression with a certain number can make the denominator have a value of 0. And we know that if a fraction has a denominator of 0, that expression is undefined. So in these cases, we say that there are restrictions on the expression. So let's look at three examples, and for three examples, let's list all numbers for which each rational expression is undefined. In other words, let's identify the restrictions. So for number 1, we want to think what value of x would make that denominator undefined. So we know that if we would plug in a -2 for x, that would result in a denominator of 0. And that means that -2 is our restriction. X cannot equal -2, otherwise the denominator would be 0, which would make the term undefined. Let's look at the second example. In this example, our denominator is a trinomial, and it's less apparent what values of x would make the expression undefined. So anytime that we can, let's factor our denominator, and by factoring our denominator, it'll help us identify the restrictions more easily. So I'll keep the numerator the same, but the trinomial I'll factor into its two binomials. And if I factored it, it would be a +4 and a -1. Now let's look at our two binomials. Let's look at each binomial and think what values could possibly make the denominator undefined now. For this x, if we would plug in a -4 for both of them, we would end up with -4 plus 4, which would make that first binomial equal 0. And 0 times anything is 0. So that would mean that our denominator would be 0. So -4 would be our one restriction. And for this x, if I were to plug in a 1 for that x, all right, or both x's in that case, and my second binomial, I'd get 1 minus 1 would equal 0. And 0 times anything would be 0. So my other restriction is 1. So here there were two restrictions. And let's look at our third example. In our third example, again, I don't know exactly right now what my binomial, restrictions are, because my binomial can be factored. So let me factor that binomial in the denominator. And to factor x squared minus 7x, all you can do is factor out a greatest common factor of x. Now that it's factored, let's see what values of x would result in a 0 in the denominator. If I would plug a 7 in for my x's, that binomial would be 7 minus 7, which would equal 0. And 0 times anything would be 0. So 7 is my one restriction. And my other restriction, if you think about the other x there, would have to be 0. Because if I would plug 0 into both of my x's, I would end up with 0 times some number, and again, that would result in a denominator of 0. So I have two restrictions for this example. Try two examples on your own by pausing the video, and in both of these examples, you'll likely have to factor the denominator before you can identify what the restrictions are. Once you have your restrictions listed, resume the video to check your answers. Okay, let's check our answers. Number 1, if we look at our denominator, we want to factor out our denominator. I'll keep the numerator unchanged for right now. In this example, if I factor out my greatest common factor, since it's a binomial, I'll factor out a 4n, which would leave me with a 2n plus 1. Now let's look at what our restrictions would be. If I would plug in a 0 in for this n, or for both n's, I would end up with 4 times 0, which would be 0, times some other number, which would again be 0. So 0 is my one restriction. But in the binomial, I have to think, what value could I plug in for this n that would result in my binomial becoming 0? So in other words, I want 2n plus 1 to equal 0, and I need to figure out what the n would be. So let's solve this for n by isolating the n variable. So if I would plug in a negative 1/2, that should result in 0 in the binomial. So if I get 2 times negative 1/2, that's negative 1, and negative 1 plus 1 is 0. So my other restriction is negative 1/2. For my second example, again, I need to factor my denominator. So x squared minus 1 factors into x plus 1 and x minus 1. And you'll notice that in the numerator, it doesn't really matter what I have up there, because for right now I'm focused just on the denominator and what would result in a 0 in the denominator. And so since I have two binomials that are multiplied together, I know that my one restriction would have to be negative 1, and my other restriction would have to be a positive 1. Those would both result in having zeros in the denominator.